Welcome back again. This is CCNP 2.0 switch. I'm Aditya. In this section that we are going to take a look about layer 2 loops, understanding the working of spanning tree protocol, configuring and verifying spanning tree protocol, and troubleshooting spanning tree protocol. So in this section, first we need to figure out or understand how does layer 2 loops occur, in what kind of problem that we can face in your network, and then how we can prevent this loop using spanning tree protocol. Since we have already discussed about the layer 2 loops, but for a moment I am going to enforce your concept and recall those things that we have discussed already. So in this section, as we can see, we have host 1 and host 2, and they have their associated MAC address. What happened, host 1 or host 2 trying to send a data that has destination MAC address is CCC, and as we can see, switch 1 and switch 2, they have a redundant link. They have two links that goes to the same direction from switch 1 to switch 2 or switch 2 to switch 1. Frame going to receive by switch 1 and switch 1 going to figure out where is the destination MAC address located, or by which port I can get this destination MAC address. Since switch 1 there is no kind of entry in CAM table or a MAC table like CCC and CCC, the destination MAC address. If you have your switch or a bridge, both they going to send out frame out of every port, except to that they listen that frame originated. So your switch and bridge first going to look up their CAM table. If there is no entry, that is known as actually the unknown unicast frame, or it could be the multicast or a broadcast frame. In these three situations, your switch and bridge going to send this frame out of every port, that is technically known as frame flooding. So in frame flooding, your switch going to send data to port number 1 as well as port number 2. And let's see, once switch 2 receive frame from port number 1, it going to figure out where I need to forward this frame, since the frame MAC address, destination MAC address is CCCCC. Similarly, like switch 1, switch 2 do not have any kind of entry regarding the destination MAC address CCC. It going to send out of every port, or more accurately or technically it's known as frame flooding. In frame flooding, your data going to send out this interface and this interface. Then after might be the second frames arise to switch 2, same task switch 2 going to perform, means look up in layer 2 table. If there is no entry, perform frame flooding. Switch 1 again will receive the same frame, again going to send out every port except to that receive, and that you can see here causing layer 2 loops. So not only layer 2 loops, I should say the endlessly layer 2 loops, until and unless you reboot your devices, recycle your devices, you cannot going to terminate these loops. Along with layer 2 loops, there is some other problem also exist, like unnecessary resources utilization or a multiple frame transmission in your link, unstable MAC table address. Since we know your switch and bridge, once they receive the frame and they associate the source MAC address to that particular port, so So earlier switch 1 no, the AAA connected to port number 3. So after sending that frame and getting reply back the same frame, switch 1 now come to know the MAC address AAA associated to port 2. Similarly with switch 2. So there is unstable MAC address as well if any kind of layer 2 loops occur, as well as unnecessary frame lookup by the host if the frame is broadcast or multicast. So suppose any kind of broadcast sent by the host 1 going to perform frame flooding out of every port, switch or host 2 going to listen on that frame, that might be not for host 2, or maybe some other device also connected. So all those devices going to look up that frame. That is a not good idea, that is not a good practical. So to prevent this problem, spanning tree protocol use so that we can block layer 2 loops. Spanning tree algorithm first written by Radia Polman so that it can detect layer 2 causing link and block till first goes down or disconnected. So that's mean one of link going to block if there is any kind of loop created. So to work layer 2 detection, loop detection, your spanning tree protocol use some kind of keep live messages or BPDU, bridge protocol data unit, that going to send out of every interface in frequency of every 2 seconds. So they going to select a root bridge, and then after they going to decide which port going to turn off and turn on. So BPDU actually perform the core task in your spanning tree path selection and root bridge selection. We'll discuss shortly, but first we need to understand what is root bridge. So now we come to know the spanning tree protocol is going to avoid layer 2 loops. In spanning tree protocol there is a terms known as root bridge that we have already discussed. It's going to elect. So this is the reference point of layer 2 topology and changes the timer on entire domain. That is the root bridge, where the timer that is going to send out of every 2 seconds you can change by the root bridge in going to automatically changing out of every switches. And propagation point of topology changes if there any changes occur, that going to send out of every switches by the root bridge. So we will discuss how does root bridge going to elect and how they going to work. Along with this, spanning tree protocol use their ports states and port role. So what is port state and what is port role? Let little bit discuss on it. A port role, why you are, what you want to do, actually why you assign for, what is your work, that is known as port role, and what currently you doing, that is known as port state. So maybe your role is you are working as a root, but sometime you may listening the frame or learning the frame, and might be you forwarding that frame. So it could be anything. So that means, so there is root port, designated port and alternate port. So let's discuss a little bit about the root port, designated port and alternate port. So let me take my marker so that I can, so for instance this is switch 1, switch 2 and switch 3, switch 1, switch 2, switch 3. Suppose this is the root bridge. Actually root bridge elected by default the lower MAC address. So the port from switch 2, the port goes to the direction of root bridge known as root port. Obviously for switch 3 this port going to become the root port, because toward the root bridge. Designated port, that is non-root bridges. What I mean to say that the link from switch 2 to switch 3, this going to become a designated port. In a port that might creating a loop going to block, or a port to reach alternate port to get the root bridge, known as the alternate port. So for switch, this is the prefer one interface that going to select as a root port. What happens if this port goes down? Switch 2 automatically going to select this port as a root. So this is considered as a alternate till your root port is exist. So if there is no root port, this will automatically going to become a root port. So applying port role and port state, your spanning tree going to block one of alternate port that might be create a layer 2 loops. So I'm not going line by line, since we have already discussed about spanning tree protocol. So I have already described very well in this document. So you can just download this document and find this link at below of your YouTube video. So BPDU used to detect layer 2 loops, select bridge root and selecting root bridge and finding root port, and synchronize topology changes and acknowledgement as well. So obviously a root bridge, all port is on forwarding state, and that port known as the designated port, because they are not going to some other root bridge. So the port that going to direction of root bridge known as root port. And now the question arises, how does root bridge election take place? Sorry. A root bridge election take place with bridge ID. A root bridge that has lower bridge ID, that become a root bridge. So to selecting root bridge, there is three kind of information that going to use: priority, system ID, and then MAC address. So priority that we can assign, this is the 4-bit bridge priority that we can configure from 0 to this amount. And then system ID extension, or more accurately, this is actually the VLAN number. So whatever VLAN you have, that going to add 1. If you may have a default configuration. So in default configuration, if I remember, let me show you. If I remember, I think it was by default 32678. I think so. Yep, 32678. Let me explain a little bit more about this. So by default 32678. If you are working in VLAN 1, that going to add 1. You are working with VLAN 2, going to add 2 and 3, and so on and so forth. So this is the priority. You can change. This is the system ID extension, that is approximately your VLAN and your MAC address. So these three value going to elect your bridge ID, and when you have a lower bridge ID, you are the root bridge. So bridge ID or bridge priority and system ID by default tie up actually. So the lower MAC address going to become the root switch or root bridge. Priority that you can change, so might be you want to make a switch intensely, you want to switch to make a root bridge that is not currently working as a root bridge. You can decrease the switch bridge priority, so that makes sure that switch or bridge working as a root bridge. So this is the amount you can increase or decrease. This is the number 4096. because we know very well 4096, a particular switch, the maximum number of VLAN can exist. That's why this is the number that you can select to increase or decrease the bridge priority. And how does system your switch going to select the path? That is already we have discussed. That is not a big deal. They are first going to bridge with the lower bridge ID, become the root, prefer the neighbor with lower port root. We'll go through the example. And the neighbor with the lower bridge ID prefer the lowest sender port ID. So the cost is main thing. Using the cost, your switch going to select which port going to become the root. Suppose this is the root bridge, and which port going to become a alternate. So this is actually based on the link cost, and link cost is indirectly proportional to your bandwidth. That means higher your bandwidth, lower your cost. If you running 4 Mbps of link, you may have 250 cost. If you running 1 gig Mbps of link, you have a cost of 4. So in spanning tree protocol, lower is better or small is better. Way to remember, as for spanning tree, as for small, the small is better. Similarly, if we discussed about the spanning tree protocol, there is several version of spanning tree protocol, but we are not going to take a look all those spanning tree protocol. So we have a legacy spanning tree that is defined by the Radia-Paulman, PVST, per VLAN spanning tree protocol, per VLAN spanning tree plus, rapid plus, and MST. So they may have some changes. As we can see, the spanning tree protocol can run single instance. Per VLAN spanning tree protocol that is defined by the CISCO can run per VLAN. So how many number of VLAN you have, you can run that amount of or that number of spanning tree protocol. And it only deal with ISL tag earlier, then after rapid spanning tree plus that can use to compatibility with .1q and ISL as well. So you can just go through the entire documents, and then after you will able to know all those things. So that is good. Now we need to figure out, we need to verify or configure spanning tree protocol. So let me pause the recording and turn on my devices. So this is the topology that we're going to work with. My devices is up and working. I'm using 2960 series of switch. This is switch 1 and switch 2, and the switch are connected with gig 0/1 and gig 0/222. And let's see which switch going to elect as a root switch or root bridge, I should say. Switch 1 or switch 2. As we discussed earlier, by default your bridge priority going to tie up, that is 32768, as well as your system ID is also going to tie up, that is actually the VLAN number. And third one or a third number that cannot be tie up is your MAC address. So the lower MAC address device going to become the root bridge. So it could be switch 1 or switch 2. Let's see which switch is working as a root bridge. So let me bring my console window and execute the command do show spanning tree. So switch 2 is not working as a spanning tree, sorry, root bridge. So switch 1 should work as a root bridge. So as we can see, the root ID is 32769. What I say is 32768. Yeah, exactly, because of the VLAN number 1 that we can see right there. And the MAC address of root switch is 7C95F3F2AA00 and 7C95F3F2B20. Since my MAC address is larger than the elected root bridge, that's why that elected the root bridge. So you cannot change the MAC address. Yes, you cannot change the system ID, but you can change the priority. If you want to make to switch to become the root bridge, you have two ways to change the priority. So one way, let's see, spanning tree for VLAN 1, you can select the priority, and then after the priority, that increment and decrement using 4096. Since we have in particular switch, we can up to 4096 VLAN can exist. That's why either you have another option, you can select I want to become the root, primary or secondary. So sometimes this is better command to execute because you may need to figure out what is the currently the bridge priority of switch 1. Since I want to be the root bridge, I should have the lower bridge ID than switch 1. So maybe switch 1 has the bridge ID 4096. So you may need to execute command using the priority 0. So then after you can become the root bridge. So better for you use I want to become the root bridge primary. Your switch automatically going to figure out what number should I decrement from the my priority so that I can become the root bridge. That is very good way to make your switch working as a root bridge. And another thing that we need to verify which port is working as a root and which port working as a alternate instead is blocking. So let me execute command again. I'm not going to make root bridge. And one more thing, I should also show you the system ID. How we can do? Let me select the interface range gig 0/122 switch port mode. I want to switch port mode trunk, and let's see VLAN 2 and VLAN 3. I created on switch 1, same on switch 2. Not I created on switch 2, same on switch 1. VLAN 2, VLAN 2 and VLAN 3. Now let's see which switch is working as a root bridge for VLAN 2 and VLAN 3. So this time I'm going to execute command on switch 1. Let me bring little bit on recording area. And let me execute command so spanning tree. As we can see, for VLAN 1 I am the root bridge, for VLAN 2 also I am the root bridge, for VLAN 3 I am also root bridge. So if you like to make switch 2 for VLAN 2 become the root bridge, you can execute the command spanning tree VLAN 2 I want to the root primary. So your switch automatically going to figure out how many number of priority I need to decrement so that I can become the root bridge. And let's see again. This time I'm going to specify the VLAN 2. We can see now I'm no longer root bridge for VLAN 2 because the root bridge that has the lower priority than mine. So this is VLAN 2, so going to add 2. So 68 plus 2 is equal to 70. So now we can see the core concept for electing or selecting as a root bridge or a root switch. Next thing, I want to make gig 0/2 root port for VLAN 2. switch 1 looking, what I mean to say. Currently for VLAN 2, gig 0 slash gig 0 slash 1 working as a root port, because this is the root bridge for VLAN 2. We want to make gig 0 slash 2 to elect as a root port, because we know first thing, that is the cost could be tie up, and then second is the priority cannot tie up. So by default, based on your port number, lower port going to elect as a root port if your cost going to tie up. But you can change the cost as well as you can change the priority. Let's see, we want to make gig 0 slash 2 to become root port for VLAN 2 for switch A, for switch 1. What we can do for switch 1? So hop over to that interface and execute command spanning tree, and cost. So for instance, I'm going to select 1. So earlier it was 4. Now I selected as 1. That means gig 0 slash 2 going to become the root port. So do so spanning tree, spanning tree for VLAN 2. We can see because of the cost I am going to become the root port. Similarly, you can change the priority, but priority not going to work with. For instance, I'm going to create a primary root bridge for VLAN 3 as well, and I want to see VLAN 3. So switch 2 is working root bridge for VLAN 2 as well as VLAN 3. Again, I'm looking for make gig 0 slash 2 port to root by changing the priority. So let's see what's going to happen. Interface, I think I'm already working on that interface. Spanning tree for VLAN 3, and then after port priority, and currently port priority, let's see the first port priority. So do so spanning tree for VLAN 3. It's 128.26. That is the default value for VLAN 3. I'm going to change the spanning tree for VLAN 3, VLAN 3 port priority 16. So now you may thinking that gig 0 slash 2 is going to become the root bridge, root port. For I should for VLAN 3 cost should be, I taken mistake I think somewhere. For VLAN 3 port priority 16. Let me make the cost is default spanning tree for VLAN, for VLAN 3 spanning tree, because of the keyboard. Spanning tree VLAN 3, numlock is off, VLAN 3 and cost is 4, that is the default one. And let's see, do so spanning tree for VLAN 3. This is the root even after we change the priority, because first thing your cost, if your cost going to tie up, then after the second thing is priority going to elect as what I say, yes, if your cost going to tie up, then after going to your priority going to select. But in this case, since for VLAN 3 I am not a root bridge, That's why even after changing the priority, I'm not able to make the root port. So let me fix it. The cost is priority. Priority is 128. That is the default value. And let me execute the same command. Yes, if we going to change that priority from the lower bridge ID that is selected as a root bridge, that then after gig 0/2 will become the root port for VLAN 3. And let's see, this is the, we can see, do so spanning tree for VLAN 3. I should be the root. Yes, I am. Let me select the interface gig 0/2 spanning tree for VLAN 2, and then port priority, let's see, 16. So from root bridge for VLAN 3, sorry, VLAN 3, it should be VLAN 3, excuse me. For VLAN 3, I change the priority. That means switch 1 automatically going to elect gig 0/2 as a root, as we can see right there. So these are the value. Based on this value, your switch is going to take decision which port going to become the root, which not. So I hope so we have clear all those things, all those topics that I have mentioned in this documents in PDF. You can download this PDF to understand it better. So in this video, this is all about. Thanks.